Okay, so my name's Anthony Spiteri. I'm a Senior Global Technologist at Veeam. It's a pleasure to be here at Tech Field Day 20 on the 10th anniversary. My first Tech Field Day experience was earlier this year at Cloud Field Day, and it was great. So, you know, what Rick sort of went through before is actually what I covered at Cloud Field Day 5 with regards to our Update 4 release for Cloud Tier. What I'm going to cover in this section is basically our V10 version of that, which is coming in a couple of months. So we've enhanced the Cloud Tier. We released it initially with that move mode, and what we're going to introduce in V10 is our copy mode and also some immutability. Okay. So what we're going to look at is just a very brief introduction into the copy mode. We're going to look into a bit more of a deep dive into the blocks and what we're actually doing. Rick mentioned that everything that we do at Veeam is simple, reliable, and flexible, but we're not afraid to get underneath the weeds and show you guys actually how our technology is innovative as well, okay? So we'll actually show you, much like what I did at Cloud Field Day 5, what's happening with these blocks of data when you actually offload them from your local performance to the object storage. I'm going to talk about resiliency. We've built some great resiliency into this Cloud Tier, which in effect makes it a DR product in itself. And then I'm going to look at immutability, which is something that's quite interesting, just as a way to protect against malicious insider threat. So let's kick it off with exactly what we've done in V10. Again, I've mentioned we've introduced copy mode. So basically the ability to copy data as soon as it's been created from the Veeam backup replication job to the object storage. We've introduced immutability, like I've talked about, and then again, that resiliency. And these three features create what we think is a brilliant and innovative product and feature of the Cloud Tier.
Can you just tell me how you've made it immutable?
We'll get to that. Yeah, that's my last bit. There's a whole section on that, so we'll basically get to that and I'll explain. In terms of the modes, so this is just a really quick overview as to the differences between the two. So Rick's talked about the move, okay? Fundamentally what this is about, it's about shifting data. We all know that data is growing exponentially and locally backup data as well. It's becoming larger and harder to maintain. Those initial landing zones, you know, which 5 to 10 years ago were talked about in the terabytes, is now talking about the petabytes. We're not talking about RUs, we're talking about racks. So the really important thing is how do we make that more efficient? How do we offload the data from the performance tier to somewhere that's fundamentally cheaper, okay? And that's what that move mode is all about. When you look at the move mode, again, I'm not going to go into the details of how we specifically do it because we're focusing on copy, but effectively we have to have a source file, which is a sealed backup chain, okay? The offload time is an operational restore window. We set a policy on the backups. When those files go out of that time, they're then a candidate to be moved up. We then have an offload period set by default at every 4 hours. So it's a background job that runs and looks at the two previous caveats and says, is it a sealed backup chain? It then sees, is it outside of that operational restore window? Then every 4 hours it'll go, what can we offload? What can we strip and dehydrate out of that local VBK file and shift it to the object storage?
So question.
Yes.
What happens if either the cloud provider is down or the connectivity to the cloud is down? Do those just kind of sit there until the connectivity comes back?
Yeah, so what will happen, it'll sit there. Obviously, that's going every 4 hours. You can actually force that as well. So it is actually every 4 hours, or you can right-click or do a PowerShell command. But what it'll do, if that 4 hours hits and you don't have connectivity to your object storage bucket or folder, it'll just fail that part. And then the next time, it'll shift everything that it had to up at the next interval. Copy mode. So copy mode differs from the point that we look at all backup files now. We don't look at the fact if it's a sealed backup chain. We will move every backup file. So for those that know Veeam, we've got a VBK file, we've got an incremental, reverse incremental. So there's a couple of different file types. What we do now is we basically will shift every file type when it's created. In terms of the offload time, it happens as soon as the backup job has created that file. And I'm going to go show you guys in a demo what that looks like and what it seems like in the actual VBR console. And the offload period is continuous because effectively, again, as soon as that job creates a file, it's going to be offloaded and copied to the actual capacity tier itself. And just to play on a little bit about what Rick said and expanding that, so when we look at the Cloud Tier copy, again, we're not stripping the actual VBK file itself. What we're doing is we're basically now adhering to this 3-2 run rule. Rick mentioned that with the move mode, we weren't doing 3-2-1 rule because effectively what we had with the move is we had that data either sitting on the performance tier or was offloaded into the capacity tier, okay? It was one or the other. It either existed on the performance tier or on the actual capacity tier. With copy, what we're doing is we're taking a holistic whole copy of that data and copying it to the cloud tier itself. Again, we can make those immutable. I'll touch on those a little bit later on. And the really important thing here, and one thing that Rick probably didn't highlight enough, was the fact that even with move mode, we strip the files back and we actually dehydrate them so we've only got the metadata remaining on premises, we can still action every Veeam restore capability. And the way that we do that is by leveraging that block index that we talked about and streaming the blocks down. So we know exactly where the blocks are sitting in object storage, and if we need to do a restore operation, an instant VM recovery, a file level recovery, a full VM recovery, we're actually going to pull those blocks and stream them. And that's a massive difference in terms of what we do and how our competitors do it. Because fundamentally what we're doing is streaming that data down. We don't need to take that data and move it and get it from the capacity tier, from the object storage, move it to a staging area, and then do something on that data that's there. We're streaming it directly down. Okay, part of the smarts behind this technology and what makes it innovative in the space.
Can I ask a question?
Yes.
One of the problems I've seen with these cloud tier is that they saturate the available bandwidth. So you might have a 1 gig internet pipe,
Yep.
and then the storage guy just blithely sends it as if it's like a data center LAN.
Yeah.
Have you got some sort of controls on there
Yeah.
to pace out the flow?
So we do have networking, speed bumps as well, so we can actually say how much you want to limit a particular upload. Uploads you want to kind of push up as quickly as possible, just for the sake of the copy and getting it up there, but you can limit it if you want. From a download perspective, if you're recovering, at that point, I think it's just as fast as you can get it.
So you don't do any smart pulsing of the circuit to gauge the bandwidth and not kill it?
We can set it. No, we can set it, but we're not going to gauge it. No. I think when you think about it from a backup perspective, if you're in a situation when you want to recover and you've got a critical system to bring up, you want to get it as quickly as possible. So there's a bit of a mentality.
The problem is that you then take down the entire company. So what's actually happening is when you do that, you saturate the inbound internet connection, and all the emails dead, websites are down, blah, blah, right?
Possibility. I mean, I haven't seen that happen very often and also what we do is we're limited by physics, right? We're limited by the object storage repository at the other end.
Yep.
Typically, Amazon S3, Azure Blob, they're limited themselves in what they can pull down.
Yeah.
So I've seen max, 5, 10, 15 megs per second, which shouldn't, cause
The reason you haven't seen it is because networking people throttle you out.
That's it. I used to work with one.
Yeah.
Hi, Nick.
Yeah. We generally choke you out, so you can't go as fast as you need.
That's exactly right.
To prevent you from, you should actually think about doing something to pulse and determine the available bandwidth.
Good on, Thanks for that. Okay, so basically between the two, the differences again, fundamentally. On the copy mode, we're copying everything across. For the move, we're stripping out the blocks and offloading them. That's the big differential between the two. The copy tier uses the same mechanics though as move, so it shares the fundamental architecture, the logic that we've put in the smarts. Data is chunked and offloaded in the same way. The one difference is unlike move, we don't dehydrate those VBKs obviously because it's a direct copy. Like move, like I mentioned, all restore functionality is retained. That's a very important point, and I'll show you exactly what it looks like in the demo. It still makes use of that block index. So we have effective source side dedupe. So when we're moving these blocks into the capacity tier from the performance tier, we're not going to shift the same block twice. So we understand that if we've got multiple Windows, multiple Linux, they've got shared blocks in a sense, right? So the archive index understands what the blocks are, and we're never going to upload the same block to the capacity tier itself. That's the key to that archive index, that block index. Effectively, we're calling that source side dedupe, okay? But effectively, it's just block reduction. We base this technology actually on ReFS. For those that understand and know about Microsoft ReFS, it's similar in the way that it does that. Both copy and move are actually supported in itself, so you can do two together at the same time, and there are absolutely benefits to doing that. And again, copy and move will share those blocks together. This is what it looks like in the actual UI, and we'll show this live in a couple of minutes in a live demo. The benefits of copy and move are interesting. I talked about the move fundamentally solving the problem of large data sets locally and offloading data and making it cheaper, okay? With copy and move, now you're getting the best of both worlds. You're getting the efficiencies of making that landing zone, that performance tier, more usable, more manageable, more capacity planning, with the copy mode, which introduces that 3-2-1 rule, protecting the data while making it more efficient. Okay, so it's like a double hit now in terms of what we're offering with this particular feature. Now let's get into the blocks and actually show you what's happening a little bit. So what we have here is effectively a representation and a visual representation of the performance tier and the capacity tier. We've got a number of our VBK files and we've got incrementals at this point. So what effectively happens here is that when we offload the files, we take the blocks of data and shift them into the object storage. And we move that through until we've got that F block. And
but I have a question. I can't take it anymore. I'm sorry.
That's okay. Go for it.
You keep saying object storage and you keep saying cloud. So when you say object storage and when you say cloud, are you saying those to be the same? And are you saying those to be an S3 type bucket on a cloud provider?
It can be either or. So we've got S3 compatible, which can be anything that's on premises as well. We've got S3 with Amazon, we've got Azure Blob, and IBM Cloud. Okay, so when I say cloud, we've got a few terminologies here. So what we've got
is IBM Cloud Swift or is IBM Cloud S3?
That's S3. Yeah,
okay.
It's effectively S3 compatible there. Yep. So when I say cloud as a destination, I'm talking about when we're talking about Azure and S3, Amazon. Okay. It could be a cloud provider, though, that's a service provider offering object storage as a service as well. Or it could be an object storage that's S3 compatible living on premises. Okay. We've got different terminologies, so that is actually part that's a bit confusing. So we have the cloud tier is, you could say, the marketing name for the actual feature overall. We've got the performance tier, which is the performance tier that is a repository that sits locally. We've got the capacity tier, which is a repository that sits backed by an object storage repository.
Okay, so what is the cloud tier again? Because that's where I'm getting confused.
The cloud tier is the marketing name
for
the
all of
product.
it?
Yeah, for all of it.
Okay.
Yeah. If in Cloud Field Day 5 we had the concept of a glossary, which went over all that, we probably should have done that again this time just to, save those questions. But effectively, that would have solved that. But yeah, it's a little bit confusing. Marketing did what they did in terms of that name.
Hey, I was a product marketer. Don't hate on them.
Yeah, no, we were in marketing as well. It's all good. All right, so effectively what we've got here is we've got the operational restore window. Now, we're only going to shift the blocks outside of that window. That's what I talked about, the policy that we set. We've shifted all these blocks out. Now, it's important to understand that when we move it into the object storage, it's just blocks. There's no concept of a VBK file in the actual capacity tier itself. Okay, it's just blocks. We just reference those blocks, then they can pull back. When we look at the copy mode, what we're doing, as soon as those files are created, we offload the blocks straight away. So incremental is created, we offload the blocks, we offload the blocks. That's a fundamental difference, okay? Previously, what we did is we waited for that operational restore windows and for the backups to get old before we actually offloaded. With copy mode, it's straight away. Now, when you combine the two, what happens is you have the copy first, okay? So we create the files, the blocks are shifted up. That's all good. That's from the previous slide. We then introduce the move, which introduces the operational restore window. The operational restore window is a policy set X amount of days. What happens in this case when we've got copy and move together, because we're aware of all the blocks that are sitting in the object storage, and we already know that in the case of A, B, and C that are sitting outside of that window, we just effectively dehydrate that file. Don't actually move anything. Okay, so pretty smart. This actually works in the inverse as well. When we're doing the recoveries, we'll actually look to see what blocks are local before we pull the blocks down. That's saving on egress charges and saving on cost as well, and also increased time to actually do the recovery.
Just understand, if you need to restore a file, it goes in the performance tier anyway, and the second restore, if I need it from the same blocks, it happens on the performance tier.
Yeah, so what happens if you're doing a restore, it'll see, in this case, say if we wanted to recover the Monday backup, what we'll understand is we'll say that if we have blocks A and B locally, we'll pull them locally first. If we don't have them, we'll then pull them from the object storage. Okay. So in theory, because we keep a certain amount of blocks locally, you're going to obviously get a high percentage of blocks recovered locally. Okay. But if you had a disaster, and this taps into resiliency that I'll talk about in the next section, if you do have a disaster, you can get it all in the object storage.
Can you remind me what's the criteria for having the blocks locally? Is that because they're, let's say, fresh backups, or is there another?
Yeah, they might not have been offloaded. So you still want something locally. So again, just remember that the move policy moves it outside of a certain window. So you still have that operational restore window, which, in this case, it's 2-3 days. Okay. Realistically, that could be 30 days, that could be 60 days. So you've got quite a bit of data there. That's the data that you want to access critically locally first for maximum speed of recovery. Outside of that, that's when you go to the performance capacity tier. In terms of the indexing and what that looks like, so Rick mentioned the metadata files that we keep in the actual cloud tier, in the capacity tier itself. So what happens is here, when we create a file, we create a subsequent metadata file in the object storage, and then we copy up the blocks and link to those blocks with that metadata file that sits in the actual capacity tier itself. When the secondary incremental is created, we create a new file, a new pointer file effectively. But instead now, because this same incremental has blocks A and B similar, all we're going to do is upload block D and point to the previous blocks in the actual capacity tier itself. So you can see there that in this case, we've uploaded blocks A and B from the initial file that we created. The secondary incremental had a similar block pattern itself. We didn't upload A and B, we just referenced it. It was already up there.
Do you support AWS S3 ILM in the backend? I mean, if I do the copy at the very beginning, and then in the backend, the S3 starts to move data on lower tiers, so less.
Yeah. So we support infrequent access, and that's it at the moment. So there's the intelligence, the new intelligence mode in infrequent access. We don't support that, but we don't support anything going below S3 at the moment. That's coming in future releases, okay? Because effectively, once we start to think about tiering off to Glacier and below, those blocks all of a sudden don't become available when we need it because there's that time to first byte. So at the moment, this technology to get all the recoverability feature works directly with S3 and S3 compatible. Yeah. Okay, let's do a demo.
Can I ask you a question before we disappear off that particular screen? We can go back again. Imagine you're in a scenario where you've been using this technology for 1-2 years, and you've got hundreds of thousands, millions, hundreds of millions of objects that have been backed up, and potentially billions of sub-objects, which are the components that make up all those backups. If there's been a bug in your software or some other sort of process issue or error, how do I know what data on my object store is still required and still not? Because every month I'm paying for that. Yeah. And if I've got no way of going through and highlighting stuff that is effectively orphaned, I could continue year on year to pay for stuff.
Exactly, yeah. So we have got checks and balances in terms of the archive tier itself. If a bug comes into play, then that's obviously something that we wouldn't expect, and therefore we would have that issue. Hopefully, we don't have a bug. That's kind of the way to answer that. But we do have rescanning techniques.
Yeah.
And one thing about going back to Rick talking about our reliability, we typically don't release. Well, obviously, we're not bug free, but the reason why we're so reliable is because we release products when they're done. So not to sort of try and sort of diversify a question, but it would be a very, very rare situation that would happen. Now, if it did happen, obviously you would have these objects that are sitting there that you're going to pay for perpetually, right? Now, there are ways to bring everything back. So the way that I would envisage that is that we have got ways to pull the data back. So what you would do is you'd basically rehydrate everything locally. Now, that obviously means you need all the space locally. Delete the bucket, whatever you've got, and then do the offload job again. You can force that. So pull it back, delete, re-upload.
How about a bucket clean function where you can put another bucket next to the first bucket, and you can move the stuff that you think is valid, and then what ends up being left in that first bucket must be orphaned?
From the point of view of we would move it itself. Yeah, we would have to move it ourselves.
You could build that as some sort of function to do something.
Yeah, we'll take that on now. It's an interesting feature request.
It's just it seems to be the biggest challenge with anything in the cloud is, as soon as you're putting something in the cloud that I can't validate is still needed, I'm going to be charged for it. I don't care whether it's on-prem and I bought the storage or it's on tapes. It doesn't matter. But when it's in the cloud, it's a different scenario.
Yeah, and look, we're very cognizant of that fact. It's why we've built in the technology like that intelligent block recovery for the back to reduce the egress charges, because we understand that everything that you do in the cloud costs money. Every operation that we do to put a block of data in there costs money, because we've got all the S3 operations as well. So we're very cognizant of that fact. But it's an interesting one. We'll certainly take it on board.
So you have a tool to recover VBK even if you don't have the server anymore, right?
Yeah.
And what happens with the object store? Can I recover from a bucket something? Because it's no longer in a VBK, but it's...
Yeah. I'm going to talk about resiliency in the next section, so we'll wait for that and then I can answer that question, if you don't mind, yeah. Okay. But if the answer is yes, we can do that. Okay. All right, now let's just quickly go through this and show you exactly some of the features and copy modes. So over here you can see we've got our backup repositories. If I go to add a backup repository here, you can see we've got object storage repository. This is where we add the different types, so S3 compatible, Amazon S3, Azure Blob, and IBM Cloud. And Gina, this is part of the question that you were asking is, this is what you do first. You've got to create a repository that is an object storage repository. So that was our first step. So you can see here that I've got 3 that are based on Amazon S3. What we then do is we go to the scale-up backup repository, and you can see here I've got 3 different instances here. They're all linked to different repositories. You can actually mix and match here. So the question earlier was, how do you actually go from one, if it's Azure or if it's S3? The answer is basically to create different SOBRs and send your jobs there, and then effectively you can cover yourself. You can send data to both platforms if you want. If we click on SOBR 01, you can see what it's comprised of is 2 local repositories and an object storage repository. If I click there and click on the properties of that, you can see here that we can go through. We've got the performance tier, which is effectively the local repositories, that placement policy, and Rick touched on this a little bit in terms of the different types of placement policies that we do have, whether we place for data, whether we place for locality. But where it comes into play now is this part here. And Gina, here's where we call it the capacity tier. Okay, so we've built and created this object storage repository. We're now extending our SOBR to leverage that via the capacity tier. And you can see here now we've got the option for copy and move. Okay, copy, what we've just talked about, and move as well. You can see here that we've got this policy here, which is basically set to 2 days. That's that operational restore window that I talked about. Now that's basically the thing that you set to dictate for the move how old you want those files before you start offloading them to S3 or to any capacity tier that you've got. The copy is instantaneous again. As soon as you create those files, it's going to shift it to the object storage there.
Is there a way with the encryption? I saw the encryption button. Is there a way with the encryption? What happens if you lose the key? I mean, where is that key? Or is there different opportunities for storing the key?
So that key is stored in it's a Veeam backup replication key. So what you'll do, typically with Veeam, you've got a configuration backup. You'll hopefully take that configuration backup and export it somewhere. And then if you have a disaster, you bring that back in. Yeah. Okay. Obviously, if you lose it and you lose the key, you're in a little bit of trouble there.
A little bit?
Yeah. It's really, at that point, the data's really secure. No one's touching that.
Maximum security potential reached.
That's immutability in its purest form. Okay.
Long-term storage.
Yeah, long-term storage.
Long-term secure.
Waiting for quantum computers to crack that key.
Yeah. So what we can see here in these jobs, and I've configured a number of different jobs here, and they're all kind of linked in a certain way. But what you can see here is I've got Cloud Tier Copy 01, Cloud Tier Copy 02. I'm actually going to start that job just to show you the mechanics of what happens with a copy when it actually comes into play. But what we can go and see in the actual jobs itself is that we'll see this job starting up. But before that, you can see that we've run this job locally before. And what's happening, once that job actually starts, it's going to do what we call an offload job. And that offload job there is going to look at every single backup file that's been created from that job and then copy it straight away to the actual capacity tier itself. And when that happens, we then get a list of the jobs and what's actually in the repository. So you can have a look here. We've got disk copy. We've now got this particular tab here, option in V10 called object storage. these are everything that is sitting in object storage. We've got the restore points, and in terms of the job, what's actually sitting there now. Importantly, like I talked about, every option there is still available. So again, even though we've got this data sitting maybe holistically in object storage, we can still do instant VM recovery, we can install the entire VM, we can actually even restore to EC2 or Amazon directly. As long as we've got that information sitting from the metadata and the block to actually point to where the data is sitting in object storage, we'll stream that data through. Okay? So
are you going to, I know we're early on, but are you going to show us a dashboard of how much storage is actually being used in the cloud? Is there a way to track that?
There is. So if we go back here, you can see, it's a little bit, let's just pull that back a little bit. But you can see here for the actual S3 object storage here, we've used 22 gigs, and we've actually set a limit there. This is what's going to tell us, yeah.
Okay.
So basically this gives you the idea of how much there is on the performance tiers and how much is actually being consumed in the object storage.
Is this the only place, or are there like alerts if you get to certain levels, or?
There's not, well, the alert is set by the free space, so but you can cap it, so you can tell it to only use a terabyte. Once it gets to that terabyte, it's going to warn you and say, you've used that space. And what it'll do at that point, if a job's running, it'll finish that job. The next job won't run after that. So we have got some sort of limits in place, some speed bumps there to make sure you don't go over your...
So it's a soft limit.
It's a soft limit on that initial job, and then when that next job runs, it'll be a hard limit at that point. Yeah, we obviously want to make sure that job goes through, gives you a warning, and then goes from there.
So what about seeing the cost of storing this? Can we see that from within the Veeam infrastructure?
Yeah, interesting. No, not at this point. Okay. So we're working hard on that to get some costings into it and actually show you what it actually does cost. I feel like in the next couple of versions we'll have that and potentially mold it into Veeam 1. So some sort of report functionality that'll say exactly what it's costing.
Yeah, but it changes from, service to service. I mean,
and that's part of the problem. Yeah, it's actually...
Wasabi is totally different model.
Yep. So that's part of the thing about us trying to model something that's correct for everything that we might do. So obviously we're looking really, and where it comes into place specifically is for our customers that want to take to Amazon S3 or Azure Blob. That's really the main areas. They want to be interested in what it's costing. So yeah, it's something that we get asked a lot, and we're definitely going to put it into play over the next couple of versions. Okay, so yeah, this is actually what I wanted to show. So you can see here that the job is running. That's the base job. And as soon as that job finishes the actual files itself, we're going to start to do the backup copy up and do the sober tiering. That is there. That job right now is actually offloading to S3. So it's going to look at those files that were just created. It's going, yep, I can see new files are created. I know that copy mode is enabled on the sober. It's just finished. Let's copy it straight away. 3, 2, 1 rule of backup. Okay, straight away, you know that your backup copy is secure in a secondary location in object storage. Pretty cool. And yeah, you can see here actually, if you have a look at the network, you can see that we're pumping data up to S3 as well, just to show that it's actually happening and it's not all smoke and mirrors. In terms of resiliency, so I talked about the fact that we've built this as a kind of a DR product in itself. So what we've done in the actual sober now is we've offered the ability to restore if you've lost a single backup file, if you've lost an extent that Rick talked about, if you've lost the whole sober, or if you've lost the whole backup server in itself, okay? And how we do that very quickly, if we've, say, managed to somehow delete a particular backup file, say on Wednesday someone's deleted that incremental, the chain is now broken, what we'll do is we'll do a recovery operation and we'll pull the block back from the object storage and effectively recreate that file locally, okay? That's probably the scenario that would happen the least, but again, it's just a way that we will self-heal the performance tier just in case an accidental deletion happens. If we have an extent that's unavailable, okay, and we want to basically recover that block from Wednesday again, what we'll do in this case is we'll look at what's in the capacity tier and pull the block from the capacity tier. Now, in terms of the restore target, we understand that we're pulling blocks A and B that's already present on the performance tier and the extent that's not unavailable, so we'll use that. If we want to pull block D, we understand the block exists in a capacity tier, and we're going to go to that capacity tier if that extent is down. If we've lost a whole sober, and we want to get block D, pretty straightforward as to what's going to happen. We're going to pull everything from the capacity tier itself. Okay, again, something that's really cool, something that's very, very much self-healing and giving you guys an option to actually do disaster recovery. And this is where it comes into play when you actually lose a whole backup server. So what happens when you lose a backup server? What you'll do is effectively stand up a new backup server. If you've got the config available, like we talked about, you'll import the config and then effectively restore the configuration and start your recovery. If you don't have the config, what you'll do with the new backup server is you'll recreate the SOBA. Now you'll recreate it with the object storage repository with the same username and password pointing to the same bucket. What that'll then detect is the fact that we've got previous blocks on that actual capacity tier, and you've got the actual option now to import the data. And what that'll do, that'll import the data and reconstruct the actual metadata files locally on the performance tier, which will then allow you to restore the data and stream it from the capacity tier itself. Okay, so again, really, really a lot of smarts in the way that we've built this, not just to have it as a method to support, efficiency of data and 3-2 run rule, but as an effective DR or even a migration strategy. This could be used for migration. Okay, very much a Swiss Army knife in terms of its capability. Okay, just want to move and quickly talk about immutability. So immutability talks about additional protection. And what we're actually trying to protect here is against a malicious user. Okay, the despondent admin who decides to delete everything on his way out. Has happened before, okay, and will keep on happening. It's basically what we call the ITP theory, the insider threat protection theory. Okay, ensuring that if you've got a malicious user, be it a hacker, be it anyone with malicious intent, you're going to protect against the data being deleted. It applies to copy and move, and it's basically persistent as well. How this happens again is when we move these blocks into the capacity tier, we set an immutability flag. And this is actually based on S3 and Amazon S3 only. Okay, so at the moment we're only supporting Amazon S3. That has what we call an object lock functionality. What we're doing is basically applying object locked on every bit of data that's uploaded into the capacity tier itself. So that's how we do it effectively.
So you're applying a separate lock on top of encryption?
Yeah, if you've got encryption enabled. This doesn't assume that you have encryption enabled. You can have encryption enabled. But what we're doing is every block of data that's uploaded, we're putting a flag on it, which is a specific flag that you can call from within S3 to now say, lock that block of data for X amount of days or X amount of time. Okay? You can use encryption with this at the same time. So if you encrypt it, you can still put the object locked on it. Okay? But they're two separate functions.
So if an admin has rights to change that flag in Amazon, isn't that a workaround?
I'll get to that.
Okay.
Because there's a couple of different ways that you can actually set the object locked in Amazon itself. Okay. Again, immutability there. Let's just walk through. I'm just going to go through here. I'll get to your point in a second because time's getting short for Michael. Okay. In terms of what we do, there's an issue of when we're updating a block and we set an immutability period, what can happen though is if that block is immutable for 30 days, but we've set a particular policy of the backup file for 7 days, you've got the situation where the block is locked and it's supposed to be immutable for 30 days, but because of the policy that you set in the job, it's only 7 days old. That's where we've got this concept of block generation and expiration. It effectively is a way or a method that we've put into play to continue to extend that block, extend the immutability object lock on it without having to re-upload from the performance tier. So again, saving on upload is what we're really thinking about here. It effectively prolongs the object lock retention for a particular object and makes that reusable, okay? Because again, we're sharing the block data between different backup sets itself. We don't want to keep on uploading that same block and have the same version of it immutable, but multiple copies of that, okay? So it's just a way to be smart about the way that we're actually doing it. To your question, Gina, about supported object storage platforms, again, Amazon S3 and S3 compatible with object locked. Now that does extend itself to S3 local as well. So any provider that's doing S3 compatible and supports object lock, that'll actually work there.
Well, my question was...
So down below, compliancy and governance mode, that's the difference. So with object lock, in Amazon, there's two types of policies. There's either compliance or governance. Governance does do what you say. If you have governance mode on an object, an admin can go and actually delete that block itself from the Amazon console, okay? With compliancy enabled, not even the root user can delete that block. So we only upload them with compliancy, which ensures that they're immutable, okay?
Okay.
Cool.
Is there ever a time when that extra Amazon lock prevents a necessary action? So if there was I don't even know what that would be, but if there was a need for that lock to come off, is there any way to get around it?
No, it's locked. It's locked in place, yeah. That's what makes it fully immutable, yeah. Okay, cool.
The thing I'm trying to figure out, and I know you tried to explain it, and maybe you could just run over it just quickly again,
Yeah.
is obviously these are dehydrated blocks. And so when you talk about immutable blocks like this, how do you handle the idea that the same block may have different policies applied to it for different time frames?
That's that generation that I was talking about. Yeah, I had to skip over because I wanted to get to Michael. But yeah, effectively, we understand that a certain block is up there. And if it's got an initial immutability period, we then add a generation to it. So we know that if a secondary period comes in, that block will be extended in the object storage and continued in there. So we're not going to upload that same block twice. But we understand that there's a period of immutability that's set in it first. And then once it actually is out of that initial period, we'll then extend the generation of that block to keep it immutable for the next period that comes into play.